Okay, I mentioned on Friday that the formulas for surface area and the formulas for volume tend to be very related when we're comparing a prism to a cylinder and when we're comparing a pyramid to a cone. So let us consider this pyramid. If I'm finding just the lateral area of it, what kind of shapes am I finding the area of? If I'm just finding the lateral area, I'm finding the area of triangles. So let's say that all of the sides in this particular instance are all equal. So the area of this triangle is just 1/2 times base times the height of that triangle. Here's a question for you. Is the height of this triangle the same as the height of the prism? Yes or no? No. Okay. So please be mindful of the fact that when we are talking about the height of something, that's how tall that figure is standing when it's resting on its base. When we are talking about finding the surface area of a pyramid or a cone, the height that we're interested in is the slant height or lateral height, depending on what textbook you're looking at. Okay, we see it abbreviated as L. Okay, that's this height here. All right, so once again, we're looking at, when I add all of these triangles together, the bases of all of them add up to the what of the base of the pyramid? The bases of all of these triangles add up to, once again, the perimeter. So this formula kind of follows very closely to what we did on Friday, except on Friday, our lateral faces were all rectangles, so they were just base times height. Here, they're triangles, so we're throwing in a 1/2. So the lateral area of a pyramid is 1/2 perimeter times slant height. And then remember what lateral area is. It's the area of all of the lateral faces. In order to find the total surface area, what do I have to add to this? One base. Clouse. Oh yeah, it was a friend. Oh, I'm sorry. I thought you had gotten in touch with them. Yeah, no. Yeah, he showed up in the afternoon. Could you just bring their next? Yeah. I'm sorry about that. Sorry about that. Yeah. Yeah, bye. Okay, so the surface area of a pyramid is 1/2 PL plus B. And again, remember what these abbreviations are. The P, remember, is perimeter of the base. The capital B is area of the base, not to be confused with lowercase b, which is just base of a two-dimensional figure. Once again, on the reference sheet, they don't differentiate between lateral area and total surface area. You have to realize that in the formula, the lateral area is the stuff before the plus sign. So in problem 1, we're asked for the surface area. Our formula, remember, our formula is 1/2 PL plus B. So looking at the figure and looking at where the markings are, do I have everything I need in order to just plug into the formula? Yes, I do. So 1/2 times, the perimeter is 8 times 4. My lateral height is 12 plus the area of my base. Well, my base is a square, having side length 8, so that's why the area is 8 times 8. Calculate. perimeter of the base. Length of each side is 8, there's 4 sides. Getting from the screen what you need, verifying your calculations match mine. We're good? Not yet. By all means, if you're waiting for your classmates to finish getting from the screen what they need, start taking a look at the next problem. So looking at the next problem, once again, this time we're only asked for the lateral area. So that's 1/2 P times L. Say that again. We don't have L this time. So any thoughts on how we're going to find L? Let us consider this triangle. Any thoughts on how we can use that triangle that I've just sketched inside the pyramid? How can we use that triangle to find L? You can't assume that it's a 30, 60, 90, but it is the right triangle, and you can use Pythagorean theorem. I know that this vertical segment is 8. Notice that the length of this segment down here will be 4.5. And the hypotenuse of this triangle is the L that I'm trying to find. So 8 squared plus 4.5 squared equals L squared. I think that's 20.25. So L is approximately 9.2. Don't clear your calculator. Remember, the fewer times you clear your calculator, the truer your answer is. Before I go any further, bless you, if there's something on my screen that doesn't make sense, you don't know how it got there, then that's a question I want to make sure to address so that you can do this on your own later. Okay? So now we have everything that we need to just plug into the formula. Once again, it's this guy. So 1/2 times the perimeter of our base is 36. That we're multiplying times the 9.2 we just found. Giving us 165.2. What I'm hearing? I love that question. Fantastic. Yes, ma'am. Okay, so you were with me up to this point here, the 64 plus. Okay, so in your calculator, 64 plus 20.25 is 80 whatever. And then you take the square root of that 80 whatever, and there's your 9.2. Okay. Like my technical terms. We have from this screen what we need. Okay, there's your turn. It is a centillo question. The only thing you're keying into the centillo is the top part of it. And the majority of you that answered did get the correct answer. Some of these other answers, I'm a little confused about where you would have gotten those numbers from. Of course, let me show you what you would have plugged in. It's asking for surface area, so that's the whole kit and caboodle. 1/2 perimeter times L plus the area of a base. So 1/2 times, it says it's a square pyramid having base edges, so I know I'm doing 5 times 4 for the perimeter. The slant height is given to us as 3, and then plus capital B will be 5 times 5. And are there still lingering questions about how did I go from there to a final answer of 55? Yes. Okay, order of operations. I'm doing 1/2 times 20 times 3. Well, 20 times 3 is 60. Half of that is 30. Plus 5 times 5 is 25, giving us that final answer of 55. Okay, suppose the slant height of the pyramid is double. How does this affect the lateral area of the pyramid? What do you think? It'll be double. Just double. Okay, so moving on to cones. As I said before, the formulas for pyramids and cones follow very, very closely together. Remember that when I gave you the formula for the lateral area of a pyramid, it had that capital P in it. What did it stand for? Perimeter. Can we talk about perimeter in the context of a cone? No, we would talk about its circumference, right? So think about it. If I took 1/2 circumference, which is 2 pi r, and multiplied it by that lateral height, how could I clean that up just a little bit? It would just be pi RL. There's a reason why I wasn't writing it on the line. And then, that is easy. Surface area of the cone would just be that lateral area plus pi r squared. And again, remember, all of these formulas are on your reference sheet. There's nothing that you have to memorize. You just have to make sure that you know how to use them, what height is important to you, depending on what you're trying to find. So you'll notice that I'm going kind of in an opposite order for this. I don't know why they did problem 3 and 4 in the order in which they did them. So that's why I'm doing problem 4 first. In problem 4, I'm asked for the lateral area. That's just pi RL. Did they give me everything I needed? Yeah. Pretty much, yes. The R, you have to think just a tiny bit. I know it's early in the morning. The radius is 3. And the lateral height, the slant height, is 12. The instructions say round to the nearest square centimeter. So you're using that pi button in your calculator. And I have 113 square centimeters. We've gotten from this screen what we need. Still getting. By all means, again, if you've gotten from this screen what you need, and you're waiting for your classmate to look ahead. Think about why I switched these problems around. Why did I switch these problems around? Right, because this one doesn't have the slant height. The other one is easier because it was given to us. This time, oh, look at how nice they are. They even drew the triangle in for us this time. Hopefully hopefully you're realizing once again, we have to use Pythagorean theorem in order to find the slant height. They gave us the how tall is it height, which we don't want in order to find area. Sir?
Height, it's not slant.
Absolutely.
All right, so like you said, it says height, but we know height, would it be the middle? Would it be in the middle?
Yes. Before I go any further, any question, dispute, concern about how to get that 13? Okay. We have 25 plus 144 equals L squared. L squared is 169. The square root of 169 is 13. Okay, once again, it's asking for lateral area. Once again, that's just pi RL. And now I have everything I need to just plug it in. The instructions do say leave it in terms of pi, so let's follow instructions. Oh, man. Pi times 5 times 13, giving us 65 pi. Okay? And have from the screen what we need. All right. And this is also a Centio question. Yes, ma'am. Yeah, just the top part on the screen. Notice on my screen it says round to the nearest whole number. I'm not going to see that. Yes, it does say that. Yes. Take the pass. Whoops, that's not what I wanted. And there we have it. Our majority answer is the correct answer, 934, of course.
Bless you.
Bless you.
4, 6, and 7 was the next answer.
Okay, let's clarify what happened to get that 934. The height is 28, not the slant height, the height. So you had to use Pythagorean theorem, 10 squared plus 28 squared equals L squared. L is some funky thing, and I loved hearing people say, don't clear your calculator. Getting in your head, that's the whole objective. So 28 squared plus 10 squared is 884, and when I take the square root of that, I have approximately 29.7. And I don't clear my calculator, ladies. Formula for a lateral area is pi RL. So pi times 10 times this 29.7 gives us 934. Once again, there was an additional question on that your turn that I want to very, very quickly talk about. Suppose the radius of a cone is halved, but the slant height remains the same. How does this affect the lateral area of the cone? What do you think? It'll get halved, okay, because the radius isn't getting squared or anything funky in the formula. And there is no Socrative quiz today. There's not enough time. Bring your workbooks tomorrow.